Our solar system can often feel like a familiar, well-mapped neighborhood. We know the planets, their moons, and the countless asteroids that drift through the cosmic dark. Yet, on a seemingly ordinary day in October 2017, astronomers at the Pan-STARRS 1 telescope in Hawaii spotted something entirely new. It was a faint speck of light, moving with a purpose and speed that defied all known behavior of local objects. This was not just another rock from our own backyard. It was a traveler from a distant, unknown star system, the very first of its kind ever to be confirmed by humanity. This discovery was not just exciting, it was a profound moment that would reshape our understanding of the cosmos and our place within its vast, unexplored expanse. The object was given the Hawaiian name Oumuamua, a word that beautifully translates to a messenger from afar arriving first. The name perfectly captured the essence of this enigmatic visitor. It had journeyed for an unimaginable length of time, possibly millions of years, across the immense gulf of interstellar space. It silently passed through our solar system, offering a fleeting glimpse into the worlds that lie beyond our own sun's influence. The initial data was baffling. It was small, dark, and moving at an incredible velocity, a cosmic bullet that had pierced the veil of our celestial home before continuing its lonely journey back into the endless night. As the data from telescopes around the world began to pour in, the initial excitement quickly morphed into profound bewilderment. Nothing about Oumuamua seemed to fit our established models of comets or asteroids. The first major puzzle was its trajectory. As it swung around the sun, it wasn't just following the clean, predictable arc of gravity. It was accelerating, pushing away from the sun with a gentle but inexplicable force. This strange acceleration is a behavior we sometimes see in comets. However, astronomers looked intently for any sign of a coma, the fuzzy cloud of gas and dust that surrounds a comet's nucleus. There was nothing. The mystery only deepened as scientists tried to determine its shape. By observing the way its brightness fluctuated over time, they concluded that Oumuamua was not a simple, roundish rock. Instead, it was highly elongated, perhaps 10 times as long as it was wide, tumbling end over end on its journey through space. Such a bizarre, cigar-like or pancake-like shape is practically unheard of for natural objects in our own solar system. These anomalies opened the floodgates to speculation and debate. The question, once confined to the realms of science fiction, was now being asked in the halls of academia. Could Oumuamua be an artifact of an extraterrestrial civilization? Was its strange acceleration caused not by natural forces, but by some form of propulsion? Was its unusual shape a sign of deliberate design, perhaps a probe or even the remnant of a larger piece of alien technology? The story of Oumuamua's discovery begins on the night of 19th October 2017. At the Haleakala Observatory in Hawaii, the Panoramic Survey Telescope and Rapid Response System, or Pan-STARRS 1, was conducting its routine scan of the night sky. This powerful telescope is designed specifically to detect near-Earth objects, the asteroids and comets that could potentially pose a threat to our planet. On this particular night, a faint and fast-moving object was flagged, initially designated P10E5V. Dr. Robert Werrick, a postdoctoral researcher at the University of Hawaii Institute for Astronomy, was the first to notice the anomaly. As he reviewed the detection data, something about this particular object struck him as unusual. Its motion was exceptionally fast, far faster than any typical asteroid bound by the sun's gravity at that distance. The more he analyzed its trajectory, the more peculiar it became. Its path was different, an open-ended curve known as a hyperbolic trajectory, a clear sign that it was not from around here. The realization dawned with a mix of awe and astonishment. This was not a member of our solar system family. It was a visitor from interstellar space, a place so vast and empty that the chances of encountering an object from it were considered astronomically small. The news spread like wildfire through the astronomical community, marking a historic moment for science and for all of humanity. A global campaign was launched, with observatories all over the world dropping their scheduled observations to turn their powerful lenses towards this fleeting visitor. The race was on to unlock the secrets of P10E5V, to understand its nature, its origin, and what it could tell us about the universe beyond our own celestial shores. With its interstellar origin confirmed, the object needed a name befitting its unique status. The task of naming celestial bodies falls to the International Astronomical Union, which maintains strict conventions. For this unprecedented discovery, however, a special designation was created. In consultation with Hawaiian language experts, the team chose the name Oumuamua. The name is rich with meaning, derived from the Hawaiian words u, meaning to reach out for, and mua, meaning first or in advance of, with the second mua reduplicated for emphasis. It beautifully translates to a messenger from afar arriving first, a poetic and fitting title for the first confirmed interstellar object to visit our solar system. It was no longer just a string of code. It had an identity. The name did more than just provide a convenient label. It encapsulated the profound significance of the discovery. It acknowledged the location of the observatory in Hawaii and paid respect to the cultural heritage of the land from which this cosmic messenger was first spotted. As astronomers scrambled to observe Oumuamua, they began to piece together its backstory. By tracing its trajectory backward through space, they determined that it had entered our solar system from the general direction of Vega, a bright star in the constellation of Lyra. However, it was not from Vega itself. The journey of Oumuamua must have been an ancient one, a solitary voyage across the galaxy that likely spanned millions, if not hundreds of millions of years, drifting through the darkness between the stars. The first detailed observations of Oumuamua's path delivered a startling surprise, adding the first major layer to its enduring mystery. As it swung past the sun and began its journey back out into deep space, astronomers tracked its position with incredible precision. They expected it to follow a path dictated purely by the sun's gravity. However, the data showed something else entirely. Oumuamua was moving slightly faster than it should have been. Ordinarily, such acceleration is a hallmark of comets. As a comet approaches the sun, the solar radiation heats its icy surface, causing the ice to sublimate directly into gas. This process, called outgassing, creates jets of material that spew from the comet's nucleus, acting like tiny rocket thrusters that alter its course. So, the logical next step for astronomers was to search for any evidence of this outgassing. They pointed some of the most powerful telescopes on Earth at Oumuamua, looking for the faintest hint of a dusty or gaseous coma around it. The results of this search were definitive and deeply puzzling. There was no coma. There was no tail. There was no dust. Oumuamua appeared to be completely inert, a dark and rocky object reflecting a tiny amount of sunlight. This created a major contradiction. The object was accelerating like a comet, but it showed absolutely no physical evidence of being a comet. It was as if a car was speeding up without anyone pressing the accelerator and without its engine running. This paradox sent theorists back to the drawing board. Beyond its mysterious acceleration, one of the most astonishing features of Oumuamua was its inferred shape. We could not see it directly as a detailed image. It was merely a point of light, even to our most powerful telescopes. However, astronomers could learn about its form by carefully measuring how its brightness changed over time. As Oumuamua traveled, its brightness varied dramatically by a factor of 10 or more over a rotation period of about 8 hours. This large variation in brightness suggested that the object was not spherical or even vaguely potato-shaped like most asteroids. Instead, it had to be extremely elongated, presenting a much larger reflective surface at some times and a much smaller one at others as it tumbled through space. Based on these light curve measurements, scientists initially concluded that Oumuamua was perhaps 10 times longer than it was wide. However, further analysis offered an alternative, equally strange possibility. The dramatic changes in brightness could also be explained if Oumuamua was not a cigar but a pancake. A flat, dish-shaped object, tumbling like a coin flipped through the air, would also produce the observed variations in reflected sunlight. Such an extreme aspect ratio is virtually unknown among the asteroids and comets within our own celestial neighborhood. Natural objects in space tend to be worn down over eons by collisions and gravitational forces into more rounded or irregular lumpy shapes. This ambiguity between a cigar and a pancake did not simplify the mystery. It deepened it, presenting two highly improbable shapes as the most likely options. Whether it was a cigar or a pancake, The extreme shape of Oumuamua set it apart from anything we had ever seen before. The strange behavior of Oumuamua did not end with its shape and acceleration. Observations of its fluctuating light also revealed something fascinating about its movement. It was not spinning neatly around a single, stable axis like a well-thrown ball. Instead, it was tumbling chaotically. Imagine a spinning top that is also wobbling erratically as it moves. This complex motion is known as tumbling or non-principal axis rotation. This meant that Oumuamua was not in a state of simple rotation, but was in an excited state, moving through space in a complex and disorganized way. For an object that has been traveling through space for millions of years, this tumbling motion is unexpected. Over long periods, the internal stresses and strains within a rotating object tend to dissipate energy, causing it to settle into its lowest energy state of rotation. The fact that Oumuamua was still tumbling chaotically suggested that it had not been traveling long enough to settle down, or that some event had recently disturbed it, sending it into this excited state. It is possible that the very event that flung Oumuamua into interstellar space was also the event that set it tumbling. When astronomers measured the light reflecting off Oumuamua, they were able to determine its color. By analyzing its brightness through different colored filters, they found that it reflected reddish light much more effectively than bluish light. This gave it a distinct dark reddish hue, similar to many of the small, distant objects found in the outer reaches of our own solar system, such as those in the Kuiper Belt, or the Trojan asteroids that orbit alongside Jupiter. This color is typically associated with surfaces that are rich in organic molecules known as tholins, which have been baked by eons of exposure to cosmic rays and ultraviolet radiation from stars. Its surface had been irradiated for millions or even billions of years as it journeyed through the interstellar medium. This constant bombardment by high-energy particles would have broken down any surface ice and altered the chemical bonds of the carbon-rich materials beneath, creating a dark, inert, and reddened crust. This crust could potentially be meters thick, acting as a protective shield for any pristine, volatile materials that might be locked away inside the object's core. One of the most profound puzzles presented by Oumuamua relates to its density. If the push came from solar radiation pressure, the gentle nudge that sunlight itself exerts on an object, then Oumuamua would have to be incredibly lightweight. For the faint pressure of sunlight to accelerate it in the observed manner, it would need to have a very large surface area and very little mass. The calculations for a solar sail scenario are striking. To be pushed by sunlight as it was, Oumuamua would need to be extremely thin, perhaps less than a millimeter thick. This perfectly matches the profile of a purpose-built solar sail. This possibility, though extraordinary, provided a beautifully simple physical explanation for both the anomalous acceleration and the likely thin pancake-like shape. Of course, this explanation immediately raises the profound question of its origin. This idea, which I proposed with my colleague Shmuel Bialy, was not based on a desire to believe in aliens, but on a sober assessment of the data, which struggled to fit any known natural phenomena. Faced with a cascade of baffling observations, the scientific community first attempted to find a place for Oumuamua within the known catalogue of natural cosmic objects. The most conservative and logical starting point was to assume it was a natural body, albeit a very strange one. The primary challenge for any natural explanation is to account for the non-gravitational acceleration without a visible coma. One of the earliest ideas was that the outgassing was happening, but it was composed of materials that our telescopes simply could not see. In the search for a natural explanation, one of the most creative theories proposed was that Oumuamua was a solid hydrogen iceberg. If Oumuamua were a chunk of frozen hydrogen, it would be incredibly lightweight and would sublimate rapidly near our sun, turning directly into invisible hydrogen gas. However, the hydrogen iceberg hypothesis faces significant challenges. The bonds holding a hydrogen iceberg together are exceptionally weak, and calculations showed that an object the size of Oumuamua would likely not survive a journey of millions of years across the galaxy. Another theory emerged that gained more traction: the nitrogen iceberg. This model suggested that Oumuamua was a large chunk of frozen nitrogen, similar in composition to the surface of Pluto. A nitrogen iceberg would be much more durable than a hydrogen one, strong enough to survive the long journey through interstellar space. It could have been violently chipped off a distant, Pluto-like exoplanet during a period of giant impacts early in that star system's history. While the nitrogen iceberg remains a leading contender for a natural origin, it requires us to assume the existence of a specific class of planetary bodies for which we currently have no direct evidence. As natural explanations began to appear strained, the extraordinary possibility that it could be an artificial object had to be taken seriously. This question prompted the Breakthrough Listen project to spring into action. They decided to use the Green Bank telescope in West Virginia to listen intently for any artificial transmissions. For a total of 10 hours, the giant dish was pointed at Oumuamua's location, scanning from 1 to 12 gigahertz, listening for narrow-band signals that would be the telltale sign of an artificial transmitter. After a painstaking analysis, the results were announced. The team had found no evidence of artificial signals emanating from Oumuamua. The object was radio quiet across all the frequencies they observed. However, the silence from Oumuamua does not rule out the possibility of an artificial origin. The object could be a defunct probe, a passive solar sail, or simply a piece of debris. The listening campaign was essential scientific due diligence, but its silence only added another layer to the object's profound enigma. The discovery of Oumuamua triggered an unprecedented, frantic race against the clock. From the moment its interstellar nature was confirmed, scientists knew their window of opportunity was terrifyingly brief. Oumuamua was already past its closest approach to the Sun and was hurtling away at incredible speed. This urgency led to a remarkable collaboration across the global astronomical community. Observatory directors were contacted, telescope schedules were rearranged, and even the Hubble Space Telescope was retasked to capture precious data. Despite the monumental effort from dozens of observatories, the data collected was frustratingly sparse. Because Oumuamua was so small, dark, and moving so fast, it remained just a faint, unresolved point of light. All of its incredible properties had to be inferred indirectly from tiny fluctuations in brightness. The race against time had yielded intriguing data, but it had not delivered a smoking gun. The messenger was slipping away, its secrets still largely intact. The fleeting visit of Oumuamua fundamentally changed our perspective on the cosmos. This realization has ignited a new field of astronomy, the systematic search for more messengers. The most anticipated new observatory is the Vera C. Rubin Observatory, currently under construction in Chile. When it comes online, it will conduct the legacy survey of space and time. This ambitious project will image the entire southern sky every few nights for 10 years. Its incredible sensitivity is expected to find dozens of interstellar objects like Oumuamua every single year. Instead of being surprised by a single visitor, we will have a steady stream of them to study. This will allow us to move from studying a single anomaly to understanding an entire population, determining what a typical interstellar object actually looks like. With a larger sample, we can begin to answer the biggest questions that Oumuamua raised. Are they all as strange as our first visitor, or was Oumuamua a true outlier? Each new discovery will help us build a comprehensive map of the galactic ecosystem. The study of interstellar objects like Oumuamua marks the beginning of a completely new field of science, interstellar archaeology. Just as archaeologists dig through layers of Earth to uncover secrets of past civilizations, we can now sift through visitors to our solar system to uncover the history of the galaxy. Each interstellar object is a probe sent to us by nature, carrying physical information about its home star system. By studying their composition, we can learn about the chemical diversity of the galaxy. This new frontier holds potential for discoveries that could reshape our understanding of life itself. If we find that interstellar objects commonly contain complex organic molecules, it would lend strong support to the theory of panspermia, the idea that life can be transported between star systems. The most profound possibility is that we might one day find something that is unambiguously artificial. If we were to find a second or third object with similarly strange characteristics, the case for alien technology would become overwhelmingly strong. The story of Oumuamua is more than just the tale of a strange object that briefly passed through our cosmic neighborhood. It is a profound lesson in humility, and a powerful reminder of the sheer vastness and mystery of the universe. Oumuamua shattered comfortable familiarity. It showed us that our solar system is not an isolated island, but a shoreline on a vast galactic ocean, and that debris from distant unknown shores can and does wash up here. This one visitor forced us to confront the limits of our knowledge and imagination. The intense debate it sparked was not a sign of scientific failure, but of strength. Oumuamua served as the ultimate scientific catalyst, forcing us to ask better questions and be more open-minded about what the universe might contain. Ultimately, Oumuamua changed our relationship with the stars. It told us that we are connected to a wider galactic community, whether that community is composed solely of rocks and ice, or of something more. We stand on the precipice of a new age of discovery, where the mysteries of the galaxy are delivered directly to our doorstep. The thrill is not just in solving the puzzle of Oumuamua, but in the anticipation of all the future puzzles that are currently hurtling towards us through the dark. The next messenger is on its way, and with it comes the promise of new knowledge, new mysteries, and a deeper connection to the cosmos. The next visitor is coming, and this time we will be ready for it.